Question 5. This question is about equilibrium. Sulfur trioxide decomposes to form sulfur dioxide and oxygen at temperature T1. According to the equilibrium shown, the graph in figure 4 shows the concentration of sulfur trioxide and oxygen over a period of 6 minutes at temperature T1. State the time to the nearest minute when equilibrium is first established. Well, it's going to be here. 3 minutes. Why? Well, remember, when equilibrium is first established, the rate of forward reaction is equal to the rate of backwards reaction. So why? Well, because as the concentrations of O2 and SO3 are constant. At equilibrium. 5.2. Sketch on the graph of figure 4 to show how the concentration of sulfur dioxide changes over these 6 minutes at temperature T1. So we know concentration of sulfur dioxide. So when we know there's 2 moles of sulfur dioxide, and the moles of sulfur dioxide is double that of oxygen. Right, so oxygen is here at 0.15. Therefore, sulfur dioxide must have the highest peak at time by 2, 0.30, which is here. And therefore, over these 6 minutes here, so it's going to plateau at 3 minutes. However, it's just going to be double the size. So it's going to be steeper, and then boom, something like that. So at 3 minutes, you know, that's when equilibrium is established. Then just stays constant from there. So that requires you to, you know, look, that's 2 moles, it's double. It's a bit of application. Then 5.3. Delta H is positive, that tells me forward reaction is endothermic. And we know in the question that temperature was changed to T2, mixture left to establish new equilibrium. New equilibrium mixture concentration of sulfur trioxide was 0.07 mole per d minus cubes. And it's currently 0.1, so it decreases. So that tells me that which way is it going to move to? Well, it's going to move to the right hand side, because if it moved to the left hand side, sulfur trioxide SO3 would increase, but it decreases. It's going to move to the right hand side, so therefore what's going to happen to the temperature? Well, the temperature is going to increase, but then it's going to shift to the endothermic direction. The temperature decreased, it would shift the exothermic direction, the left hand side. So that tells me T2 is a high temperature, an increase in temperature from T1 to T2. Explanation? Well, equilibrium has shifted to the forward direction, right hand side, endothermic direction. Equilibrium moves to oppose increase in temperature. Equilibrium moves to decrease temperature. reason I put all these keywords, forward direction, right hand side, endothermic direction, shifted, to oppose increased temperature, these are the key words that the mark scheme really likes. And sometimes you have to have a combination of them in order to get the full 1 or 2 marks. And that is the end of question 5.